We're going to look at integers and absolute value today. Integers are the set of whole numbers and their opposites. Another way to think of integers, or a more basic way to think of integers, is integers are numbers that are positive, negative, and zero. Zero is not considered positive nor negative. It has its own value of zero. So those are the three kinds of numbers we're going to be looking at: positive, negative, and zero. And when it says opposites here, opposites basically mean what it sounds like. It's the opposite of the number. For example, -2 and 2 are opposites. -6 and a +6 are opposites. That's what it means when it says opposites. So obviously we have a negative value of the number and we have the positive number on the number. I wanted to take a look at the number line here, and I know it's kind of small to see here, but just remember that numbers increase on the number line the further you go right. So the further you go right, the bigger the number gets, and the further you go left, the smaller the number gets. What gets tricky here is if you look at the number line, if you look over here at just the positive number side, the numbers are getting larger and they're getting bigger, and most of us know that. However, if you look at this negative side over here, the further you go left, the larger the numbers get, but the smaller the value gets. So the -4 is actually bigger than -10 because it's closer to the right. Even though when you think of 4 and 10, you think that, well, obviously 4 would be smaller. But when you place that negative sign in front of it, it changes it. So the further you go right, the bigger the number. We're going to try in this next slide here. We want to try to write the following numbers in order from least to greatest. One way to help you think about doing this is think about a number line. You don't actually have to draw a great, neat, organized number line. Just think about it. Here I've got a number line, and I've got 0 in the middle. Remember, 0 is not positive and not negative. And over here, we're going to kind of just do little tick marks. 1, 2, 3, 4, 5. There's -5. 1, 2, 3, 4, 5. Here's a +5. So remember, as your numbers go to the right, the bigger their value is. So looking here, we're going to try to find the smallest number. The smallest number is going to be the number that is furthest from the left. So 12 would be way over on the right side. -3, that's on the left side. 0's in the middle, 0's still bigger. -12 and -7. The smallest value here is -12. It's going to be the number that is furthest on the right on that number line. Next would be that -7, that would be after, and then -3. 0 would be in the middle. And then we have our positive numbers, which I don't imagine there being any trouble placing those in order from least to greatest. So there we have it. We have those numbers in order from least to greatest. Just try to remember that the further you go right, the bigger the number gets. And if you get stuck, draw a number line. You can draw a number line for any of these kinds of problems to help you. Next, we want to look at writing the opposite of each of these numbers. The opposite of a -6 is the positive value, which would be +6. The opposite of a +90 is the opposite value, which would be -90. And since 0 is not positive or negative, the opposite of 0 is just 0. Now let's look at absolute value. Absolute value is the distance from 0 on a number line. So again, you're going to think about that number line. Distance cannot be negative. Therefore, absolute value is always the positive form of the number. It's basically saying that any number, whether it's positive or negative, when you're finding the absolute value, it will always end up being positive because absolute value is distance, and you can't have a negative distance. Even if you go backwards, you're still going the same amount of a distance. So here it says to write the absolute value of each number. So here, and I want to go ahead and point out what the absolute value bars look like. They look like just bars that encounter and enclose the number. That's basically saying, what is the absolute value of -13? Well, the absolute value of -13 is +13. The absolute value of 1 is still 1. Notice I did not change it to negative. You're not finding the opposite, you're finding the absolute value. The absolute value of negative 7 is a positive 7. All of my absolute values are all positive. They always have to be positive. Even in this instance with that positive 1, it's still a positive 1. Nothing changes. So now we want to use our knowledge that we have on absolute value to solve these problems. So we're going to look at this very first one. It's an addition problem. I want to first deal with the absolute value bars. Absolute value bars are a lot like parentheses when you think of PEMDAS. You want to get rid of your absolute value bars before you start dealing with your numbers and your operations. So the absolute value of 14 is 14. The absolute value of a negative 5 is a positive 5, and we are adding. So the answer to this first one is a 19. Here, the absolute value of negative 11 is a positive 11, minus the absolute value of a negative 6 is a positive 6, and 11 minus 6 is 5. The absolute value of negative 5 is a positive 5, plus the absolute value of 4 is still 4, so we have 9. The absolute value of a negative 27 is a positive 27, divided by the absolute value of negative 9, which is positive 9, equals 3. The absolute value of a negative 4 is positive 4, times the absolute value of 6 is 6, so we end up with 24. And last one, the absolute value of 56 is still 56, divided by the absolute value of 8, which is still 8, so we end up with 7. I hope this made sense. I hope this is helpful with your integers and absolute value.